So I am recording, and today I am going to record and then upload this video to YouTube. And I am not streaming. Why am I not streaming? I'm not streaming because my internet is down. So I will just record and then upload this video as it is to YouTube, right? I could have chosen to not do this at all and continue when I have my internet, but I don't know. I had to record. I had to do assembly language for 2.5 hours today. So yes, and I'm not learning assembly for a streaming. I am streaming for assembly. So learning assembly language has a higher priority than streaming it. Yep. And so yesterday we were at here aggregate data types and about the end. We were at about the end. Yep. Automatic variables which are only available in the block that is being executed and are not accessed and are lost after it, something like that. And then we had to write programs. C, yes, we had written this program in assembly, aggregate data types. Yep, initializing an array. In C, we got this arrays of structures, initializing a structure data type in C. So we have to write uh, we have to write some assembly code to initialize some structure in C. Let's see. I guess this does not take up a lot of space because if it does, then I do not have a lot of space on my Mac. If it does take a lot of space, then we would have problem. I would have to stop the stream and then start recording again after I have cleared up some space, and then I will join the videos and upload the combined video. Item, go to my languages folder, then to assembly, and what is the code? Initialize an array, initialize structure dot s. So what do I need? What is the structure? First of all, it has first name. Okay, it has a string that has first name, then a string that has a last name, then a single byte, and then an integer that takes 32 bytes. Okay, so in the dot data, I will have to store two strings, name, or wait, first, which will have dot s keys type, and that would be Jatin, me, and then first, last, as keys, this would be the surname, Raghav. And what else do I need? Integer, I can store it directly without using any address, and a single byte of data, I can store it directly without using any address. I will be storing this data type in the stack. Now, in the dot text section, I declare that there is a global thing which can be accessed from outside the function called main, and I would like to align things by 2 bytes. And then what do I want? I will define the main label. What does the main label do? It first of all it stores, like the good people it is, it first of all stores the values of the frame pointer and the linker register onto the stack after pre-incrementing the stack by the necessary number of bytes. After storing it, it does the actual job. It first loads the address for first and last. How does it do that? Okay, how to do that? Wait a minute, let me fix the lights. God damn it. Yep, es funktioniert jetzt. Now, in the zeroth register, I will get the address for the page address for first, and then add to it the offset for first. And in the first register, I will get the address for last name, not second. For that, I first have to get the page address and then add to it the offset page of. Yep. Now I have both the addresses for both the strings. Now I need to store them onto the stack. For that, I need some space on the stack. And what is the amount of space that I need? Well, well. Here I tell len1 is the length of the first name. And what is the length of the first name? It will be stored in a single byte, and the length is equal to current minus the first. Yes, this should give me the length of the first thing, and then to get the length of the second string, I have to do, it will take a single byte, and I think it should be first minus current. Let me think. How does it grow? It grows from 0 to later. So yeah, it has to be current, that is dot, minus the label, and here also the same, minus last. Now I need to get lengths of those strings. For that, what do? I will use the second and the third register for that. First, I will get the address of the page for length 1, and then add to it the offset for length 1, and then I will get the actual value by r load into the second register the value the value that is at the memory location whose address is in the second register, and then get in the third register the address of length to to's page, and add to it the offset, and then get the actual value that is stored at that address. So at this point, I have the lengths and everything. So yep, or I can tell the maximum amount of length that a name can take, which is the way that they have done this. So this seems more natural instead of getting the length of the strings. This seems more like C. So, yep. Now, what is the space? 30 for the first string and 30 bytes for the second string, and 1 byte for the this class, which is a unsigned character, and then 32 bits for the grade. How much is this? 30, 30, 30. It is 93. So I need to have 93 bytes. Let me have sub from the stack pointer. No, and save it in the stack pointer. What is the value? 93. Let's do 95. Or or I can be a little bit genius and store them properly. Let's say this one, well, not just say it does take 32 bytes. So, but I will store this one in 8 bytes to get a round of figure. So 8 plus 32, 40. And these two, I will also store them in 32 bytes. So 40 plus 64 essentially is 102. No, is 104, which is it divisible by 8? It should be. Divided by 2, it is 52. Then by 2, it is 26. Then by 2, it is 13. So, yep, I have space on the stack. Now I need to store them. Let's say the 32-bit integer that I want to store is in the second register, and the value that it stores is this value. And then the 1-bit char that I want to store is in the third register, and the value is, the maximum can be 256. Let me use 5. And now here I need to store all of these onto the stack. Well, I can store the 32-bit integer value that is in the second register directly at where the stack is. So store at the stack this value that is in the second register, register number 2, at the place whose address is stored in the stack. Then I want to store this 1 byte value. So this will have an offset of 32 from the stack. So store the value in the third register at the place where there is stack, and add to the stack 32. Yep, that makes sense. And then store the contents of the first register, which is the string, not the contents, but the address that is stored in the. That is crazy. Shit, I don't have to do all this. I'm not storing the array directly here. I'm storing the address. So an address takes up um oh wait, uh wait, 64 bytes. Yes, 64 bytes. That is 8, like 64 bits. That is 8 bytes. Ah shit, that was crazy stupid. 8 bytes for this, 8 bytes for this, 1 byte for this, and this does not have to be 32 bytes. This 32 bits, which is 4 bytes. So this does not has to be 104. All of these, this is 4. I can also take this as 4, and 4 plus 4 is 8. 8 plus 8, 16 plus 8, 24. Thus 24. Us being stupid. Add 4 to it, or yeah, add 4 to it, and then store this address at the stack pointer after adding 8 to it. Why 8? Because we are adding 4 for this thing and 4 for this thing, and then store the address at the 0th register at the stack pointer with an offset of 16 from the stack pointer. Now this should do it. We have our structure in the stack. That is cool. How is it that they have done it? Mm, 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 mm. Offset to the first name, get the address of the first name, stir copy. They're actually storing the things onto the stack. That is also okay, I guess. Initializing an array structure in C. Initializing an array structure in assembly. Very efficient initialization in assembly. Improved initialization in assembly. Initializing an array of structured data in assembly. Okay. Otherwise, it goes there and in the array. Where is the declaration of the array? Here. Dot red, dot blue, dot green. Wait, did it store the labels like name and stuff? Nope. Through which we can call them? Nope. It directly stored the thing into the stack. That is crazy. What is .equ and I cannot even check on the internet. I do not have internet right now. This is all I have. And it is recording. That is good. Now, move, move, move. Pre-compute width into height into size. Okay, what are they trying to do here? They're trying to initialize an array of structured data in assembly language. What is .equ? I do not fucking have the internet to check it. That is crazy. Global main, then we store the frame pointer and the link register onto the stack. Then we call malloc to allocate the memory. Okay, into 0th register we move the number of bytes that we want. Then we call malloc and compare zeroth register with null, and if it is null, not equal, it is not equal to null, then end if compare zeroth and this, if go to end if, go to here if it is not equal to null. But if it is equal to null, then move number 1 to the zeroth register and then return, that is this, return. Otherwise go to end if, and what do I do in end if? I get number 100 into the third and fourth registers, and number 000 into fifth, first and second registers. Getting number 0 into the second register is the part of loop 1 somehow. Oh, yes, it should be a part of the loop 1, because after initializing w1 to 0, my first loop has started, and the first instruction that I execute inside that loop is initializing the second integer, the second counter, that is I equal to 0. And then after that, initializing that, my second loop begins. And this is what I do in my second loop. I multiply and add the contents. I multiply the contents of first and third, that is whatever is the first counter, multiply that by the contents of the third register, that is 100 width, and add the contents of the second register. This, which makes sense. This gives us the index, and I store that into the ninth register. That makes total sense. So at this point, the ninth register has the index. Like, yes, this is equal to the address, equal to getting the index for I image. And then what do? At I add the contents of the zeroth register to 9. So 9 has the offset at this point, that is the index, and I add that to the zeroth register content, and zeroth register has the address that I got using malloc, and then I store it in the ninth register. So at this point, ninth register has the address, memory address, which I can use to store my data. And then what do? I store a single byte from the fifth register, that is 0, into the ninth register at the address of the ninth register by adding an offset of red, green, and blue. What is the offset for red? It is 0. For green, it is 1. For blue, it is 2. And then what do? I add the I increase the second number by 1, the second counter by 1, and then I compare second by third. And what is third? Third should have width. Third should be equal to it. When my second counter, that is going from width 0 to the highest width, it becomes less than or till it is less than or equal to the width, I continue executing this loop. But then when it is not, at the when the point comes when the counter grows greater than the width, I get out of second loop and I work here. I increase the first counter by 1 and then compare it with the height until it is less than or equal to, I continue executing the second loop. But when I have done that, I call free. Uh, and what are the parameters that I provide to free? The address that I got using malloc in the zeroth register. I free that memory and then I move 0 to 0 free up that memory and exit with an exit code of 0. Makes sense. How can I improve this? Here is an improved version, apparently. First of all, I move into the 0th register, the number of bytes that I want. Then I call malloc. Then I check if if I got the value or not. And if I did got, then if I did not got, then I continue here by moving one to the 0th register. That will be the exit code. And then I return. But if I got some memory, I move on to here. What do I do here? Here I first move the total number of bytes. What is size? Size. Height, width, and I size. Size of one structure is 3. 1 byte for blue, 1 for green, and 1 for red. So 3. This is the total number of bytes that I need. It is stored in the 0th register, and then I move 3 into the third register 0 and into the first register 0. This is initializing something to 0. What is this? W3. This is just randomly doing W3 equal to 0. And then I store at this location. At the start, I get the address by adding counter to the base address that I got using malloc. Here is the base address that I got using malloc, and to that I add the counter. What does that do? That will give me some counting space. What is the thing by which the counter increases? The counter must increase by 3, I guess. Yep, it does increase by 3. So after getting the address, I store the values of individual pixels in the structure, and then I increase the counter, then I compare it with the total number of bytes, and till it is less than or equal to, I continue my loop. And then at the end, I free and exit with the exit code 0. And here is the most efficient code. What do? I store the frame pointer and the link register, and then I move the total number of size in the 0th register. I malloc, get some space, and check if I got some space and do appropriately exit. If I did not, then I start this my loop execution. So third register has 0, fourth register has 0, second register has the total number of bytes, and then I add the contents of the second register, that is the total number of bytes plus the address to get the last address. Okay, get a pointer to the end, move end address back to equal boundary. Then I OR. Then what do? I OR the contents of second with the contents of F, or so what will this give me? This will give me something in the first register, then I subtract from the second register the contents of the first register. Okay, why am I doing that? And then I move the base address to the 9th register. Okay, what does the 0th register has at this point? move end back address to quad boundary. End address has to move to a quad boundary. F means 1111 and taking OR with 1111, I get the first 4 bytes and then 1111. And if I subtract that from the from the contents of the second register, will I get a quad boundary? I subtract from second the contents of first. The first register has bitwise OR. Get number of leftover bytes. How does this give me the number of leftover bytes? And then, okay, this somehow gives me the number of leftover bytes from the end. Okay, then I subtract the leftover bytes to get at a boundary, good boundary. Then I move the base address to ninth, and then I store pay the third and fourth register at the ninth address, the contents of the ninth, and then I compare ninth with the end till it happens or not, and then I continue the loop. While I less than end minus 1 go to loop, clear quad word I plus that. Oh yes, I am post incrementing the ninth register here. Okay, and then clear the leftover spaces. How do I clear the leftover spaces? By post at this point. This is at the last address that I used to store something, and then I put 0 to that, clear byte. Byte by byte, I put 0 there. Subs from the first register, subtract 1. Okay, and subs, this will store it there, and then okay, and so the leftover bytes become 0 through this loop, and then are done. I have free and move on. That also makes sense. Now, exercises. What do I have to do in the exercises? I hope that this does not take a lot of space on my MacBook. If it does, then it would be a problem. Okay, what does it mean for a register to be volatile? Okay, which AArch64 registers are considered volatile according to AArch64 function call convention? For a register to volatile, it means that when I branch to a subroutine to call that, the registers whose value I can expect would be changed after that subroutine returns, and the program counter starts executing the code after the call, after the branching function or branching instruction for that subroutine. The registers whose value I can expect to be changed are called volatile registers. And which registers are considered to be volatile? Well, from 0 to 7th registers are considered to be volatile, and 8th register is a special, but it is also volatile, so I can consider its value to be changed also. And registers from mm, 9th to 16 are also volatile, and the rest of the registers are non-volatile. That is, if I am calling a subroutine with some specific values in registers from 16 to 30, I can expect to find their values as they were before calling that subroutine. And if I'm writing a subroutine and I want to do some things, store some data, and do some calculation in those registers, in those non-volatile registers, then I first have to store their data onto the stack and do my stuff there. And then after exiting the subroutine, I can get their data back and store them back into the register and exit the subroutine. Fully explain the differences between static variables and automatic variables. That is a crazy question that I do not know the answer to, or maybe I do know. I have to look for it in my mind palace. Sherlock Holmes, motherfucker. Fully explain the differences between static variables and automatic variables. Static variables are the variables that are stored on the stack, and automatic variables are the variables which are stored in the registers, and that is the only place that they are stored in. Static variables are stored in the stack and can be accessed from any point in the program, but automatic variables are only stored in the register and can only be accessed if their values have not been lost from the stack. Let's see, we had automatic variables up here. Is that correct? Automatic variables in block structured high level languages. An automatic variable is a variable that is local to a block of code and not declared with static duration. Being declared with static duration means getting some space in the stack which can be accessed throughout the program. It has a lifetime that only lasts as long as its block is executing. Automatic variables can be stored in one of the two ways. The stack is temporarily adjusted to hold the variable. Temporarily adjusted to hold the variable. The variable is held in a register during its entire life. Okay, and what are the static variables? Static variables. I would think that those variables are some things that can be that are stored more permanently and can be accessed from outside where they were declared. Okay, it's not here. Static variable, static variable, static variable, static variable. Okay. Oh, the data are read only and block started by symbol sections contain constants and static variables. So it is stored in the data read only or basis section of a program. Okay. And the address of a dynamic variable is always stored in another variable known as a pointer, which may be an automatic or a static variable. Equivalent static variable declarations in C. Okay, these are the static variables and they are stored in the data in data set. Okay, makes sense. So automatic variables are temporarily stored on the stack or in the registers only during their entire lifetime, but static variables are declared at the start of the program and are stored in the .data section of the program's allocated memory. That makes sense. Chapter 2 summary. Static variables. Whoa. It is used again, the word in chapter 12. Now, in AArch64 assembly language, write a function that is equivalent to the following C function. Okay, this function takes in two integers a and b. Integers are 32 bit long, that is 4 bytes. If a is greater than b, return a, else return b. Okay, and I know where I have to take the parameters in the 0th and the first register. Chapter 5. This is no chapter 5. Okay, in the dot, do I have to declare something in the dot data section? Nope, I can go directly in the dot text section, and there I will say that I have something called global, and align the things at 4 bytes mark. And in the main section, first, like a good person, I will store the frame pointer and the link register contents onto the stack by pre-incrementing the stack with the amount of storage that I need. And then I declare a function called max, a label called max. So I can call max whenever I want. Max, here is the declaration. Max, this would expect that in the 0th and the first register there are two word values, like two word, two different words. One word is in the 0th register and the second is in the first register. Then I compare. Now I conditionally select and store one of them in the second register. Well, yes, first I have to compare them. Compare the 0th and the first register. Now select if the thing is true. If the thing is true, then, and what is the condition that I'm going to check? The condition is greater than. Is that right? Yes. If the contents of the 0th register, that is the first parameter, if it is greater than the second one, then I want to store the 0th register. Otherwise, I want to store the contents of the first register. Okay, and now the I can directly store it in the 0th register. This is crazy. And then I can just wait, return. And how can I do that? I can just branch to whatever is in the link register. That is literally crazy. Okay, let me provide it the numbers. Move in the 0th register, let's say this number, uh, not like in 64-bit number, 32-bit number integer, and in the first register this number. I guess the contents of the first register are winning here. Then branch link, branch to the max function with these things in the 0th and first register, and L means link, that is in the 30th register, that is the link register. It will store the address of the instruction that I am going to write, that is the next instruction. Because when I exit from here, I can just branch to this instruction and thus return the function in that way, in that sense. Yes, at this point I would like to print what I got. In the dot data, I will have to declare a string which will be stored in the ASCII's format, and the max number is %d new line. Now I want to print. For print, what do I do? Like first, okay, in the 0th register I have the max number, so first of all I would like to move it to the first register, because with the 0th register I got some stuff to do. In the 0th register I will get the address of the string. For that, I first get the page address, then add to that the offset. Now I have the address, I have the integer, I have to store that integer onto the stack. For that, I make some space onto the stack, sub, or just like store the contents of the first register onto the stack after I subtract from the stack 8 bytes. Yes, and then I can just branch link printf function, and then I first deallocate the stack, that is why adding to the stack pointer value 8, and then I restore the frame pointer and the link register contents by load pair 29th and x30 from the stack pointer and add to it 16 after loading these values. Then I can just return with the exit code 0. This should work, right? What are the things that can go wrong? I don't think there are things that can go wrong here. Chapter 5. Error. Is the number too big? Is it literally greater than... Okay. So the number seems to be greater than 2 billion. 1, 2, 3, 1, 2, 3. How is this number greater than 2 billion? Okay. This one would be okay, but I have to provide address, right? The address where I want to branch. Where is the address? Right. Move this expected compatible register or logically immediate. What is wrong? Move. I just moved this to the 0th register, but now there is error for moving this. And why is that? Why exactly? Move into this, and move into this first register, this value. Okay, there is still error with this expected label or encoded integer printer offset. I can use the ret function, right? Yep. Ret will return to whatever is the address in the 30th register, that is the link register. And lang bus error, and we got bus error last time because we were messing up with the stack pointer. So I have to subtract from the stack pointer some value, let's say 8 bytes, and then I can store directly onto the stack, store, and then here I add to the stack. That makes sense, yes. And then I clang it, then output, and then I get bus error. Okay, so there is still something that we are messing up, some place that we are messing up. In chapter 5. Maybe the thing is this we are storing 32 bytes, but we are giving using the store function. So let's use a whole of 32 bytes, 64 bytes to be stored there, and 64 bytes is 8 bytes. Okay, that would make sense, more sense. Oh, nope, I made a mistake in the line 25th. I have to add 8 because 8 is the amount of bytes that I got. Still error. Yesterday we were getting the same error, but we fixed it somehow. Let's do 16. This is the maximum number. Okay, let's change the numbers to include something bigger. Clank. The number seems to be too big. Expected compatible register type. Okay. Let's use the whole register for this. Right. This should work now. Oh. The number is too big for the instruction. Alright, I get it. The number is too. So these instructions are stored as they are, but this number can be too big. And when the number is too big, we have to use these equal to store these integers in the literal pool, and storing these in the literal pool as an offset from the program counter is handled by the assembly language. We don't have to worry about it. So pretty cool. I don't have the internet. I could have checked how to store integers in the literal pool in AArch64 assembly, but we have to go with trial and error here. So the problem that we are facing here, I get it. The problem is this. These instructions take 32 bits to be stored, and there is a certain amount of bits that these numbers, these immediate values can take, but the immediate value that I'm providing here is exceeding that bit limit, so it cannot be stored directly in the instruction when I compile this. So these immediate values have to be stored as an offset from the program counter, and then they will be called when this instruction is being executed. So what I can do actually is store them here in the .data section using a quad 32 64-bit space. This is my number, and num2 will also be a quad, which will be this number, right? And then I will first load their addresses ADRP by getting their address page address first, and then add to it the offset page off, and then I'll get the actual value. How do I get the actual value? By load into the 0th register the value of the memory location whose address is in the 0th register. Now I do the same with the second number, but with the first register. num2 page add to the first register the offset for num2 and then load the value into the first register whose address is at the first register. Overflow we see. We are seeing some overflowing stuff. The number is too big for a 32-bit number. So what is what is this delimiter for a 64-bit integer? I can reduce the size here. And this can be around 2 billion, right? 1 2 3 1 2 3 1. Okay, this should do it. 1 2 3 1 2 3 1 2 and 3. Yep, this should do it. We should not see an overflow now. Oh wait, we got the lower number somehow. Bigger number is this. Hey, the way we are checking is not correct. Then compare the contents of 0th and the first register, and if the first register is greater than, okay, x0, oh, replace this with x, replace this with x, replace this with x, replace this with x, and this also. Maybe if this is true, then I get this value, and if it is false, then I get this value. Conditionally select. Let's see. I still get the wrong value somehow. Why am I getting the wrong value? At this point, after getting the values in the 0th and the first register, I call the max function, which overwrites the contents of the first 0th register with the correct thing. Conditional select. Conditional select. What does this do? Condition and this C select. If condition is true, I get the value of Rn. If condition is false, I get the value of Rm. That makes intuitive sense, but it is not working here. Conditional select. If the condition is true, if 0 is greater than the other thing, then I get the value of the 0th register. Otherwise, I get the value of the first register. And then I return. And when I return, I go back to this point. I store, move the value from the 0th register to the first register. Or I can first store that value here directly from the 0th register onto the stack, and then get, after storing the answer of the max function onto the stack, I can later update the 0th register with the address of the string that I want to print, then call the printf function and do my dirty work. Now I get the correct number. Wait, what? No, that is not the correct number. 512. This should be the correct number. What the heck is happening? Okay, I am getting some messed up numbers. Maybe the numbers are too large. Let me remove one more digit. Blank and then output. This seems to work. 512 and the number. So the number was larger than 32 bits. Therefore, things were messing up. Now, moving on to the next question. Question number 4. What are two places where an automatic variable can be stored? Well, an automatic variable can be stored either in the register or temporarily on the stack. Those are the two places that an automatic variable can be stored. And I will have to go to the washroom. I can stop recording, but that would just stop the whole recording. But then I pause. Yup, me back. I went to the washroom and you guys didn't even know. That is just crazy technology. Like Star Wars. I haven't watched Star Wars, but still crazy. You are writing a function and you decided to use registers 19 and 20 within the function. Your function will not call any other functions if it is self-contained. Okay. Modify the following skeleton structure to ensure that 19th and 20th can be used within the function and are restored to comply with the AArch64 standards. That is, they are not non-volatile, but without necessary memory accesses. So I first do this, then I do this. Okay, without necessary memory access, I can store them onto the stack. Yes, I can store their values onto the stack, and then after the function has worked, done its course, I can get them back from the stack. That's just it. That is just it. I can store them onto the stack, and after the function has done its working, I can get them back from the stack. Now, this convert the following C program to AArch64 assembly using a post test loop. There's a do while loop. Post test. This is the function I want to convert. Chapter 5. Comment the shit out of it. This is my C code. I should learn Vim macros. That would actually help. This it is equal to. It is equal to. Oh shit. Yeah, this should do it. Comment on this also. Now, what do I want? I want to print a string called hi. So I will need a string in the .data section that would store in the ASCII format the letters for hi, and then the .data section I say that I have a thing called main that is global, and I align everything to 2 memory spaces to 4 bytes boundary at 4 bytes boundary, and then I have to run a loop 10 times and check after. Have a post increment. So first I initialize a counter, move to the 0 first 19th register. Shit. Move. Oh, okay. First of all, like any good person, I have to store the frame pointer and the linker register contents onto the stack by post incrementing the stack by pre-incrementing the stack by 16 bytes. Then I have to initialize the counter in the 19th register, but there is a problem. The 19th register is a non-volatile register, so I have to store its value onto the stack, and then after I have done my work, I will get that value back from the stack. So store the contents of the 19th register onto the stack by pre-incrementing it by 8, and then I can initialize the counter in the 19th register starting from 0. And here is my loop. The loop, the loop, the loop. Ah shit. I have to use another register to make this process faster. Let's say the 20th register. Store pair these and that, and instead of 8 subtract 16. Store pair. Okay, why is this like that? Because there has to be a comma there. Okay, in the 19th register, 19th non-volatile register, why am I using a non-volatile register? Because I will be calling the printf function again and again, and I want to have my counter not changed by the printf function. So that is why I'm using the 19th register, that is a non-volatile register, and I'm using the 20th register because I do not want to lose the address of the string that I'm going to print, so that I do not have to load the address again and again from the data section. I have it already. Move into the 20th, not move, but get the page address in the 20th register for string page, and then add to the 20th register the offset for that. Okay, and in the loop, the first thing I will do is get in the 0th register the address from the 20th register and call the printf function bl printf, and after the printf has executed, do I check or do I update? First I update first. I update the 19th register first, and then I check what is the 9th. Yep, not move, but add to the 19th register value 1, that is updating it, and then compare the contents of the 19th register with 10, and if it is less than or equal to 10, then I would like to loop back to the loop. But if it is not, then I will first of all ldr ldp load the pair 19th and the 20th register values from the stack, and then also update the stack, clearing the memory that I used there to store their original content, and then I also load back the contents of the frame pointer and the link register from the stack. And then I just return. This could be wrong. I cannot add 1 add to the 9. Yes, because I am stupid, right? Yes. That is not how the add instruction works. It has to have a destination register and a register which describes the value that it has to add, to. And hi. Okay, now question number 7. How many questions are there? There are 13. We are halfway there. Write a complete AArch64 function to shift a 128-bit value left by any amount between 0 and 127 bits. The function should expect its arguments to be in register 0, X1 and W. The lower 64 bits of the value are present in zeros. The upper 64 bits value are present in the first register, and the shift amount is passed in W2. Okay, this is doable. How would I do? Should I can't access? Okay, Excalibur seems to be offline. That makes me happy. Okay, so I will have zeroth register will have the lower 64 bar. Wait. This is the X0. This will have the lower 64 bytes. This is X1. This will have the upper 64 bytes. And the amount that I have to shift will be in the W2, the lower 32 bits of the secondary register. I was saying byte. I meant to say bits here. So if I want to shift these, then I I will first of all store the contents of this register into the, well, instead of just explaining it, I can actually do it here, here. Now go to the top. Would I need something in the data section? Nope, I would not. Well, actually, I would need something in the data section to show the number that I have printed. Uh, String will store ASCIIs, and the ASCIIs original is %d, %d, %d. Oh, I can write this org to present original, and new is also ASCIIs, and new is %d, and new line character at the end. Then in the dot text section, I have something called main that's global, and a line at 4 bytes memory. Then I am describing the main function, the main label, which is this, which is going to be as follows. It will first of all store the stack pointer and and the stuff. It's not the stack. It cannot store the stack pointer. It stores the frame pointer and the link register contents onto the stack by pre-incrementing the stack pointer by 16, that is 16 bytes. Then I move. Crazy shit. I will have to describe the numbers in here. Num LSB will be quad. And this is the LSB. Okay. And then MS. Shit. What is the way that I printed a 128-bit number earlier? What did I use here in %d? I have to remember, or I can just look up here 128. Okay, page number 128. Unsigned integer. What is some equivalent C code? 128, 128, 128, 128 MBs, 128 MBs, 128. Multiply operations with 128-bit result. Okay. This is the C code, and it is %LX. Is that it? Is that it? Is that it? Yep, it seems to be %016LX. They talked about this in here. Okay. 016% LX. LX means large number, 64 bits probably. Yes, I said bits. That is correct. 64 bits. And 16, what does 16 represent? 16, 64 divided by 16, that is like 16 nibbles. And increment them by 4. 16 nibbles, because one represent this number in 16, that is hexadecimal, and use 0 to fill up the spaces before them. Okay, not this, but 016LX, that would be the original number. Well, two of them, 016LX, and here I would have 016LX percent 016LX, and here is the number 0b. In binary it is this. I can write 64 bits here. Dot quad 0b 0. Suppose these are less than 64, but yeah, it works. So now I have to get these into the 0th and the first register respectively. So ADRP get the page address into the 0th register for the LSB by doing that, and then add the offset to the 0th register for the LSB, and then load the 0th register with the value which is stored in the memory location whose address is at the 0th register. Then I do the same for the MSB with the first register. Add to the first register MSB page offset, and then load the first register with that value. Now I can here branch link the function shift. I will call the function shift, and here is the definition for that shift function. Okay, and I also have to provide a offset. So move register number 2, the offset would be 10. It can be 100. Now here in the 0th register I have the LSB, and in the first register I have the MSB. I will store the MSB in some other register. So move the contents into the 3rd register, the contents which are in the 0th register, right? And then logically shift left the contents of the 0th register with whatever is the value in the first register in the 2nd register number 2, and then so the LSB has been shifted correctly. Now I would like to shift the MSB. So and yes, store that into the into that register, into the 0th register, and then logically shift left the contents of the first register and store them in the first register, and how many bits, whatever is in the second register. So I have shifted the MSB and the LSB. Now the space that is here in the lower bits of the MSB, I have to fill that up with whatever was shifted out of the secondary register. And how do I do that? I do that by this first, and then I have to logically shift right the contents of the third register, which contains the LSB of the original number. I shift it right by the remaining amount. Let me think. Okay, I want to have get the uh, most significant bits, and how many MSB I want from the third register. I want the same number of MSBs that is in the Wth register, in the register number 2. And how do I do that? I first update the second register by subtracting and storing, subtracting from 128, 7, 128. If I have 1 as left shift, how many time, how to get the MSB? 1, 2 minus 1. Yes, subtract. Yes, I have to subtract from 128. Now I have the value of this, and then logically shift right and store into the third register the contents of the third register. By how many times? By the number of times that is in the register number 2, and then add and store in the first register the contents of the first and the third register. This should work, this should work, this should work. And then just return. This should actually work. I'm hoping that it does. So first of all, I will print. No, I do not want to print the original value. I will only print the new value. Well, shit, I can. I should actually print the original value in here before calling this. Oh, I have the values here and here in this register and in this register. In the 0th register, I would like to have the address. Shit. Yes, after this I can store these onto the stack, these numbers. How do I do that? To do that, I get some storage in the stack by subtracting from the stack, or like I can directly store them by store the pair 0 and 1. Is that the order I want to give them to it? Nope. I want to give the first register here and the second one here. Yes, that is the order that I want to give in, because first register contains the MSB, and store them onto the stack by pre-incrementing them by 16. Okay, I have at the stack these values, and then I want to load the 0th register with I want to load the 0th register with mm, um, I want to load the 0th register with the address of the string, the original string. For that I do drp get the address, page address in the 0th register for arch, and then add to the 0th register the offset for arch. That should do it. And then I can call the printf function. Okay, I got this much. And okay, and then I want to get the MSBs and LSBs back into the 0th and the first register, not respectively, and then call the shift function. For that, I can get the values back from the stack pointer, just like that. From the stack pointer, I will not pre-increment the stack pointer. I just let it be. After calling the function, I know that I have something good going on there. I can now store these values back onto the stack to call printf once again. -16, but I will not increment it, like decrement it permanently. I will use the stack pointer as it is. Then, and what do I want? I want to get this new string label address in the 0th register. For that, I get the first I have to get the page address in the 0th register for new, and then add to the 0th register the offset for that. And then I think we are good to go. We can call the printf function after that, and after calling the printf function, yes, we can return. No, first we have to clean the stack that we messed up. How do we do that? We add first of all to the stack pointer 16, that is clearing up the space in the stack we used to store our 128-bit mega number, and then get back the frame pointer and the link register by loading the pair 29 and 30 from the stack and then adding 16 to it. I hope this works. This will not work. Like, this thing will not work. This might work. Es funktioniert nicht. Oh, we were facing the same problem earlier, right? We wanted to shift with whatever the value was at some place. Okay, this one will be easy. I can move this number into a register and then wait a minute. Yes, I'm back, and we were fixing this error. So I can fix this by moving the number 128 into a register and then subtracting it. But how did we fix this when we wanted to provide the value, the amount of times that we want to shift a number into a register? Okay, I am speaking gibberish right now. Yep, here. Before doing that, I can move into, let's say, register number 4, the value 128, and then instead of this, I can use register number 4 here. This should fix that error. How do we fix the other one? I think that problem was in this. And where is logical shift? Here, and here it is not complaining if I am providing a register. Logical shift this many amounts and store it into this. Okay. Line immediate must be an integer. Okay, invalid operand for instruction. Immediate must be an integer. Logical shift right. Invalid operation for instruction. Operand for instruction. Do I shift left, shift right. Immediate must be an integer in chapter 5. Okay. Here I do not have to subtract from 128 and shit, I am being stupid. I can subtract. Hmm. 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 If I say that the shift amount is 10 bits, then I shift left. I want the most significant those bits. So this has to be 64 instead of that. But if the number is greater, the amount of shift is greater than that, then I will get a negative number. Okay, let's see how this works. How did I do it in the chapter number 4, logical shift? Okay, at places I am providing immediate value, but at other places I am providing the whole 64 bits of a register. So let's try to do that instead of using saying W. I can provide say X and here also X using the whole register. I see this should fix some or all the problems and then not work at all. Or the exact number that give it enough spaces so that they align properly. Okay, before calling this for the second time, what am I doing? I am shifting them onto the stack. I can directly shift them to the stack and not subtract 16. Bus error? Did it shift? Yup, it did shift. And what was the shift amount? Okay, 10 here represents 4. So how many are there? One, one, 2, 3, 4, 5, 6, 7, 8, 9. That is a strange amount to shift with. 36, and I don't think it was 36. The number that I provided there, it was 100. Let's say if it is 1, it should have been 25 zeros, if I'm not mistaken. Let's say 4, then I should only see 1 0 at the left. I do see 1 0, only 1 0. And let's say I shift it by, what is 4? 16. I should see 4 zeros. I do see 4 zeros. If I shift it by 100, I should see 25 zeros. Or maybe I did saw 25 zeros. I'm just too stupid to count them. If I provide 64, I should see quite a few zeros. 64. I should see how many? 64 to 16 zeros. No, it goddamn wraps itself. Well, the MSB changed completely, but this did not. This wrapped itself around, and this did not change at all. This is just like a new number which was not present at the start. This is a completely new number. 42. Okay, we can give our time up for quality, so we will not compromise with the quality of the thing that we do. What is this? Where am I messing up? I shift the LSB by the amount that is set in the second register. Logical shift left. It is not arithmetic shift left, and it is not rounded shift left. It is logical shift left. And here I am storing them. Storing STP, store pair, first and 0th onto the stack. First, I stored them here like this by pre-incrementing the stack pointer by 16 bytes to get a new 16 bytes of storage, and then I loaded them back into their respective cells. Then I called the shift function with their values, and then I stored, after doing that, I stored them back onto the stack, and I did my dirty work. But why is this not working now? I copied the LSB into the third register here. Then I left shift the LSB 0th register by whatever is the amount in the second. Whatever I do, instead of 64, I do 60. What do I see? I see what I would like to see. This is completely goddamn amazing. This is working perfectly till 64, but then after that it starts messing up. Why does it do that? Okay, it does it because, okay, this is good, this is good, when it is 64, let's see what happens here. I get 0. What happens here? I get 0. And what happens here? I get 64 in the fourth register, and then I subtract from 64 the offset, that is 64. Therefore I get 0 in here. Then I logically right shift the third register with 0 and store that into 0. Then I add the the whole uh, LSB of the original number into the first register. This should work actually. Blank out. Es funktioniert nicht. If I left shift a value by 64, I should get 0. Or I can do shit. I can make special cases if the value is 64 and if it is greater than 64. Mhm. And chapter 42 here I can check if the entered value is 64 or greater, and if it is 64 or greater, I will have special means to deal with that. So do I have to do this? Yup. Before anything, I have to first check if it is 64 or not. Ah, shit. So I will have to create a branch. Mm, mm. Yep, I will have to create a branch here. But I do not like the idea of creating a branch. So what do I do? I have it is working perfectly good for values. Well, how does it work for 0? Let's see. I should get the exact same value, which I do not. So I have to check for 0. Nah, I do not want to check for 0. What does logical left shift do for 0 input? It does not logically left shift. And as we have seen here, it does not. And 64 logically left shifting by 64 also does not left shift. And if I have 64 here, 64 here, okay, and then if I do that, okay, I will. So if I have 0, then what are how many MSB I want from the original numbers LSB that should be added to the original numbers MSB. If the shift amount is 0, then I do not want any bits, right? And if I do not want any bits, then I should type here 63. If the amount is 0, then shifting it by 63 should give me 0 bytes. It should give me 0 bytes to be added. Yes, that works. And okay, if I get 64 as the input, if I subtract this, I will get -1. So now I have to deal with the cases when it is 64 and higher. Okay. What do I do? First I compare the contents of the second register with 64, not 42, 64, and branch. Ah, I'm branching. Shit, I don't should not. Well, I can directly branch without updating the link register. That would work perfectly fine. I can branch to 60, and if it is not equal, then okay. Here, this is the let's say end thingy, and this works fine for under 60. And if it is not, just branch to end at the end, and I have to branch to 60, which handles the case when the shift value is 64 or 64, let's say. So when 2 is greater than or equal to 64, then I branch, otherwise I do not. And what does this do? 64. If it is 64, then the 0th register becomes 64. Well, I can just, and this is easy, move into the first register, that is the MSB, the contents of the 0th register, and move into the 0th register, 0, right? And then I have to left, yes, I subtract, move into the 4th register, 128. We can fix this with trial and error, and then subtract and store into the 2nd register the contents of 4th and 2nd. So if this is 64, right, then what is the amount by which this has to be opposite? This has to be 2, this should be 4. So if it is 64, then so stupid. I subtract 64 and I will get the, if I left shift by 0, yes, okay, and then I left shift, logically shift left the contents of and store into the first register the contents of the first register by whatever is the amount in the 2nd register. And if it is 127, then I will left shift by 63 times. This works, this actually works. Now error. Oh, okay, what is the shift amount? 0, okay. And if it is 60, then we know that it will work. Let's just check to be sure. I messed up. I messed up in this. I changed it to 63. I should not have. Do I actually have to create a separate branch when the shift amount is 0? Shit, that is just terrible. That is literally terrible. Then compare x2 with 0 and branch if equal to 0. What is 0? 0 is this. What does 0 do? 0 just, no, I can just go to the end, branch to the end. It is working correctly for 64, 60 bits. Let's see if it works for 64. I expect to see the whole MSB being changed into the wait, it is working, it is working, it is working, it is actually working. And chapter 5, 64, and if I am shifting it by 100 bits, I expect to see 0, 100, 25 zeros in the start. I will not count it, of course. Let's see. Clang. That seems to be 25 zeros. Well, till this point, I know that these are 16 zeros because of, well, these are 16 zeros, then these are 1, 2, 3, 4, 5, 6, 7, 8, 9. 16 plus 9. That seems to me like 25. So it is working. Right, we did that part. Now moving on to the next question. Or chapter 6, but the next question. Right, we did this, we did this, we did this. Now we are on to question number 8. Will we be able to do this today? Well, nope. I also have to go to college. We will have to cut short. I guess this will be the last question that we do today. Write a complete subroutine in AArch64 assembly that is equivalent to the following C code. There is a function called byte copy, which takes an array of character, two arrays and character, and then a integer named count. Then it subtracts 1 from count, and then iterates count times till count is -1, and if it is -1, then it goes back. And what does this do? Dest count equal to source count. Well, so count is the bytes, byte offset, number of bytes in the source and the destination array, and I have to copy to the destination from the source. That would be easy. First up, before that, I will have to go to the washroom again.